Right now, far out over the Pacific Ocean, something is quietly getting bigger. You cannot see it from the ground. If you walked outside in California today and looked up, the sky would look calm, maybe a few clouds. Nothing scary at all. But way up high, above the ocean, a river is moving through the air. Not a river of water on the ground with rocks and banks. A river made of moisture floating in the sky. And it is pointed straight at California. This sky river is carrying an amount of water that is honestly hard to believe. It holds more water than the largest river on Earth, more than the Amazon. It stretches so far across the ocean that if you could actually see it with your own eyes, it would reach from the California coast all the way past Hawaii, and then keep going. It is long, it is narrow, and it is packed with more water than your brain can easily picture. Here's the part that should get your attention. In about 3 days, the front edge of this thing could reach the coast. And when it hits land, that water does not stay in the sky. It has to go somewhere. It can pour down as rain for hours and hours without stopping. It can fill rivers until they spill over their edges. It can pile snow so high in the mountains that whole roads vanish. It can push a giant lake so full that the people living below the dam have to grab what they can and run. And the wildest thing of all, none of this is made up. This exact kind of storm has hit California before. When it did, it flooded towns, broke through the walls built to hold water back, and forced huge numbers of people out of their homes. One time, long ago, a storm like this turned a giant valley into a lake so wide you could have sailed a boat across it for days and days. So how does a river end up floating in the sky in the first place? Why does California, out of everywhere on the whole planet, keep getting hit by these things? And how do scientists know one is coming before it even shows up? Stick with me, because the answers are stranger than you would guess. Let's start with the river itself. Part 1. The river in the sky. For a long time, most people had no idea these sky rivers even existed. You will not find them in old weather reports. The name we use for them now, atmospheric river, is pretty new, but the thing itself is old. It has been shaping California for longer than anyone has been alive to watch it. People just did not have the tools to see it clearly until recently. So let's break down what it actually is in the simplest way possible. You know that the air around you is not empty. It has water in it. Not water you can see, but water in a hidden form floating as a gas. On a humid summer day, when your skin feels sticky and the air feels heavy, that is a lot of water hiding in the air. On a dry day, there's much less. The air is always carrying some amount of water, everywhere, all the time. Now, near the middle of the Earth, close to the equator, the ocean is warm, really warm. Warm water heats the air above it, and warm air soaks up water like a sponge. So the air over those warm tropical seas ends up loaded with moisture. It is thick with it, heavy with it, full to the brim. Here is where it gets interesting. The air up there does not just sit still. Winds high in the sky grab that moist air and stretch it out into a long, narrow band. Picture squeezing a huge amount of wet air into a thin ribbon, then flinging that ribbon across the ocean toward the north. That is basically what happens. The wind acts like a conveyor belt, and the moisture rides along it for thousands of miles. That ribbon of moisture is the atmospheric river. It is a hose, a giant fire hose, really, made of nothing but sky and water aimed across the ocean. And these things are not small. A strong one can carry more water than you would ever believe. Scientists like to compare it to the Amazon, the biggest river of flowing water on Earth. And a powerful sky river can move even more water through the air than the Amazon moves along the ground. Just sit with that for a second. A river you cannot see, floating over your head, carrying more water than the mightiest river on the planet. And this is the part that always gets people. For most of human history, nobody knew these things were up there at all. Sailors got soaked by them. Farmers watched their fields flood because of them. But no one could actually see the shape of the thing because you cannot see water hiding in the air. It took machines high above the Earth, looking down at our planet, to finally reveal the truth. When scientists started looking at pictures of the whole ocean from up high, they saw them. Long glowing ribbons of moisture, curling up out of the tropics and reaching toward the coasts, over and over again. Suddenly a mystery that had puzzled people for ages had a face. The floods were not random bad luck, they were rivers. Rivers in the sky, following paths across the ocean, aimed like arrows at the land. Once you know they're there, a lot of things start to make sense. The really wet winters, the years the lakes overflow, the years everything floods at once. It is these rivers, showing up, dropping their load and slipping away. They have been running the whole time. We just finally learned how to watch them. Most of the time, an atmospheric river is actually a good thing. A gentle one drifts in, drops some rain, fills up the lakes and leaves. California actually needs them. A huge chunk of the water people drink and use to grow food comes from these storms. Without them, the state would dry up. So they are not villains. They are more like a delivery truck that shows up every winter with the water the whole state depends on. But not every delivery is gentle. Some of these rivers are weak and calm. Others are monsters. And the difference between the two can be the difference between a nice rainy weekend and a full-blown disaster. Because of that, scientists made a way to rank them. It works a lot like the scale used for hurricanes. They grade each atmospheric river from 1 to 5. A number 1 is weak and mostly helpful. It waters the ground and moves on. A number 5 is the beast. That is the kind that can flood cities, wreck roads, and put lives in danger. The higher the number, the more water it is carrying and the longer it plans to sit and pour. Two things decide where a storm lands on that scale. The first is how much water it is carrying, which you can think of as how loaded the hose is. The second is how long it sits in one place before it moves on. And that second one matters more than people expect. A storm can be enormous, but if it sweeps through fast and keeps moving, the damage stays smaller. The truly dangerous ones are the storms that park themselves over one spot and refuse to leave, pouring down on the same towns and the same mountains hour after hour after hour. Same amount of water, but aimed at one place instead of spread out. That is the difference between a storm that fills the lakes and a storm that breaks them. And the storm forming over the Pacific right now? The early signs point to a strong one, not a gentle little number 1. Something with real punch. The kind that scientists lean in and watch closely because they know how fast it can turn from a helpful rain into a serious threat. But here's the tricky part. Even the experts cannot be totally sure exactly where it will land or exactly how hard it will hit until it gets close. A tiny shift in the wind way up high can move the heaviest rain by 100 miles. That is not because the science is bad, it is because the sky is wild and hard to pin down. So all anyone can do at this stage is watch, get ready, and wait to see which way this giant hose decides to point. Before we go further, a quick favor. If you're enjoying this so far, hit that like button and subscribe. This channel is all about taking the huge, powerful forces that shape our planet and breaking them down so they actually make sense. No boring science class talk, no confusing words, just the real story explained like a friend would tell it. So if you want to understand the world you actually live in and be the person who finally knows why the sky does what it does, you will want to stick around for more. Okay, back to it. Now we know what this sky river is and how much water it hauls, but that leads to a bigger question. Why does California, out of everywhere, keep getting slammed by these storms? The answer is hiding in the shape of the land itself. Part 2, why California keeps getting hit. Here is something strange about California. It sits right in the path of these sky rivers, like a catcher's mitt waiting under a fly ball. But the ocean is not the whole story. The real reason California gets hammered so hard is not out at sea. It is standing right there on the land. It is the mountains. Run your eyes down a map of California, and you will see a long spine of mountains near the eastern side of the state. That spine is the Sierra Nevada. These are not gentle little hills. They are tall. Some of the peaks reach higher than 14,000 feet, poking up into the cold, thin air near the top of the sky. They rise up out of a flat valley almost like a wall, sudden and steep. Now think about what happens when that sky river loaded with moisture comes racing in off the ocean and runs straight into a giant wall of rock. The air cannot go through the mountain. It cannot go around it fast enough. So it does the only thing it can. It climbs. All that heavy, wet air is forced to rise up the side of the mountain higher and higher. And here's the key. As air climbs, it gets colder. You already know this, even if you have never thought about it. The tops of tall mountains are always cold and snowy, even when it is warm down below. High up means cold. So the air rising up that mountain wall cools off fast. Remember how warm air holds water like a sponge? Well, cold air is the opposite. Cold air cannot hold much water at all. So when that warm soaked air suddenly gets squeezed up the mountain and turns cold, it cannot hold on to all its water anymore. It has to let go, and it lets go all at once. That invisible moisture turns back into real water. It falls out of the sky as rain, or if it is cold enough, as snow. And it does not fall as a light drizzle. It comes down in buckets, in sheets, in amounts that are honestly hard to imagine. Some of the heaviest rainfall ever recorded in the whole country has happened this exact way. When a sky river slams into a mountain and the mountain wrings it out like a wet towel. This is the secret behind California's whole relationship with water. It is a two-sided deal, and both sides come from the same trick. On the good side, this is how California fills up. The rain and snow that pile up on those mountains become the water the whole state lives on all year long. The snow sits up high through winter, then slowly melts through spring and summer, feeding the rivers and the lakes and the farms down below. It is like a giant frozen water tank sitting on top of the state, filled up by these storms and slowly drained all year. That snow is not just pretty, it is survival. And here's a fact that surprises almost everyone. A big share of all the water in California, the water people drink, the water that grows the fruits and vegetables in your kitchen, comes from just a handful of these storms each year. Not from steady rain all winter long, from a few big sky rivers that roll in and dump most of it in a small number of days. If those storms show up, the state has water. If they do not, the state dries out and slips into drought. That is a scary thing to depend on. Imagine your whole year's supply of water arriving in just a few visits from a delivery truck and never being sure if the truck will show up, or how much it will bring, or whether it will bring so much that it floods your house on the way in. That is life in California. But on the bad side, that same trick is exactly what makes these storms so dangerous. When a really strong sky river hits the mountains do not just gently fill the tank. They dump. A single storm can drop a big slice of an entire year's worth of water in just a couple of days. And the ground and the rivers and the towns down below were not built to handle all of that arriving at once. Think of it like this. Imagine you have a bathtub and you want to fill it. Turning the faucet on low and letting it fill over a few minutes is fine. That is a gentle storm. But now imagine you dumped a swimming pool's worth of water into that same tub in 5 seconds. It goes everywhere. It floods the whole bathroom. That is a strong atmospheric river hitting the mountains. Same tub. Way too much water, way too fast. So the mountains are a blessing and a curse at the same time. They catch the water California needs, but when the storm is big enough, they turn a helpful rain into a wall of water crashing down the slopes. And there is one more thing that makes this dangerous. Water flows downhill. That is obvious, but it matters a lot here. All that rain and melting snow up on the mountains does not just stay up there. It rushes down into the rivers, and the rivers carry it toward the flat, low places. The towns, the farms, the valleys. Some of those places sit low and flat and close to the rivers, which makes them beautiful and great for growing food, but also puts them right in the path of the water when the rivers get too full. So now you can see the setup. A sky river full of water, aimed at a wall of mountains, sitting above valleys full of people. That is the whole recipe for trouble, written into the shape of the land. But even that is not the scariest part, because one big storm on its own is something California can usually handle. The real nightmare is not one storm at all. It is what happens when they show up one after another, and the ground never gets a chance to catch its breath. Part 3, the real danger is not one storm. Let's talk about the worst thing these sky rivers can do. And here is the twist that most people get wrong. The biggest disasters are not always caused by the single strongest storm. Sometimes the real danger comes from a bunch of storms that are not even that big on their own. It is all about timing. And to see why, you have to understand what happens to the ground. Think about your backyard or a park after it rains. The first bit of rain soaks right into the dirt and disappears. The ground drinks it up like a sponge. That is what soil is supposed to do. It holds water. It absorbs the rain and keeps it from flooding everything. But a sponge can only hold so much. Keep pouring water onto a sponge that is already soaked, and the water just runs off. It has nowhere to go. The sponge is full. That is exactly what happens to the ground during a big storm season. The first storm rolls in, and the dirt soaks up a lot of it. Good. But then the ground is wet, heavy, full. And if a second storm shows up before the ground has dried out, that new rain cannot soak in. It just runs straight off the surface and into the rivers, all at once. The rivers rise. And if a third storm comes right behind that one, and a fourth, the rivers keep climbing with nowhere to put the extra water. This is the real nightmare. Not one giant storm. A line of storms, marching in one after another, back to back, never giving the land a break. Think of it like a row of dominoes. One domino falling is not a big deal. You just stand it back up. But when they are lined up close together, one knocks into the next, which knocks into the next, and suddenly the whole row is going down and you cannot stop it. That is what a line of storms does. The first one soaks the ground. The second one has nowhere to put its water, so the rivers rise. The third one pushes those already high rivers even higher. By the time the last storm arrives, the whole system is right at the edge, and one more push sends it over. And there's another problem that makes it worse. After a big storm, the rivers need time to calm down and drop back to a safe level. That can take days. But when the storms come this close together, the rivers never get those days. They are still swollen and angry from the last storm when the next one arrives. So each storm starts from a worse place than the one before. It is like trying to empty a sink while someone keeps turning the faucet back on before you finish. You never get ahead. You just keep falling further behind. Scientists even have a nickname for it. They call it a storm family, because the storms come in a group, like relatives showing up at your door one at a time, and none of them will leave. And when a family like that lines up over California, the results can be brutal. This is not a scary story someone made up. It really happened, and not that long ago. A few winters back, California got hit by 9 of these atmospheric rivers, one right after the other, over just a few weeks. 9. The ground never had a chance. It was soaked after the first couple, and then the rest just piled water on top of water on top of water. The result was a disaster. Walls that had been built along the rivers to hold the water back, the ones people trusted to keep them safe, gave out. Water poured through the gaps and flooded the towns and the farms on the other side. Whole communities had to leave their homes in the middle of the night. People died. The damage added up to billions of dollars. And here is the wild part. Not one of those 9 storms was some record-breaking monster on its own. It was the pileup that did the damage. It was the ground never getting to dry out. A medium storm hitting soaked ground can do more harm than a huge storm hitting dry ground, because the dry ground can still soak some of it up. The wet ground cannot. That idea sounds simple, but it is the key to understanding why these storm seasons get so deadly. Now, there is one more danger hiding here, and it is a truly frightening one. It has to do with fire. California burns. Wildfires sweep through the hills almost every year now. They leave the land scorched and bare. When a fire burns a hillside, it does not just burn the trees you can see. It burns away the roots and the plants and the grass that normally hold the dirt in place. It bakes the soil hard, almost like the surface of a clay pot, so water cannot even soak in. So picture a hillside that burned last year. The plants that used to grip the soil are gone. The dirt is loose and bare. Now aim a strong atmospheric river at it and let the rain pour down. The rain hits that bare, hard ground and immediately runs off. But it does not run off clean. It grabs the loose dirt, the rocks, the burned wood, everything, and drags it downhill. It builds into a churning wall of mud and rock and debris, moving shockingly fast. This is called a debris flow, and it is one of the most terrifying things a storm can create. It is not like a slow flood you can walk away from. It is a fast-moving river of mud and boulders that can smash a house to pieces and bury a street in minutes. Sometimes there is almost no warning at all. This happened in a small California town after a big wildfire. Heavy rain fell on a hillside that had recently burned. In the middle of the night, a wall of mud and rock came roaring down through the community. It destroyed homes. It killed 23 people. It happened so fast that many never had a chance to get out. That single awful night is one of the reasons that today, when a storm is coming, the people in charge treat burned hillsides as a special kind of emergency. A flood is dangerous, but mud coming down a burned slope is a whole different level of danger, and everyone has learned that the hard way. So this is the picture now. It is not just about how strong one storm is. It is about how many come in a row. It is about ground that is already soaked and cannot take any more. And it is about burned hillsides just waiting to slide. Put all of that together and you can see why the storm forming out over the ocean has so many people watching it so nervously. But here is a hopeful turn. People are not helpless against these storms anymore. In fact, some of the smartest weather work happening anywhere on Earth is happening right now, all aimed at giving California a fighting chance. And part of it involves flying an airplane straight into the middle of the storm. Part 4. Racing the storm. Here is a question worth asking. If these storms are so powerful and so dangerous, how does anyone get ready in time? The storm is way out over the ocean, thousands of miles from land. How do you even know how bad it will be before it arrives? The answer is one of the coolest parts of this whole story. Because the people who study these storms do not just sit back and watch pictures from space and hope for the best. They go out and meet the storm head on. They fly planes right into it. It sounds a little crazy, but it is true. There are special aircraft flown by trained crews that take off and fly out over the open ocean, straight toward the incoming atmospheric river. And then they fly right into the thick of it, into the heart of all that moisture. Why would anyone do that? Because a picture from space can only tell you so much. From way up high, a satellite sees the storm from the outside, like looking at a wrapped present. But to really know what is inside, you have to open it up. So the plane flies in and drops little sensors down through the storm. These sensors fall through the clouds and the moisture, and as they fall, they measure everything. How wet the air is, how fast the wind is blowing, how much pressure is pushing on it. They radio all of that back to the crew and to the scientists on the ground. And that information is gold. It lets the experts see inside the storm to understand exactly how much water it is carrying and where it is likely headed. With those numbers, their forecasts get sharper. They can tell, better than ever before, where the worst rain will fall and when. It is honestly one of the boldest things people do to protect each other. Think about it. The whole world runs from these storms. When one is coming, people board up, sandbag their doors, and get as far from the danger as they can. But there's a small group of people whose job is to do the exact opposite. When everyone else is fleeing, they climb into a plane and fly toward the storm on purpose. They fly into the very thing that everyone is scared of, so they can bring back the numbers that keep everyone else safe. Every sandbag placed in the right spot, every family that leaves early enough to survive, traces back in part to those flights out over the cold, gray ocean. And while the planes are up there gathering clues, a whole different set of people are getting to work on the ground. In the towns most likely to flood, crews start clearing the storm drains so the rain has somewhere to go instead of backing up into the streets. Fire stations set out piles of sandbags for people to grab and stack around their doors. Officials look at the map, find the neighborhoods sitting lowest and closest to the rivers, and start knocking on doors or sending alerts telling people to be ready to leave. None of that can happen at the last second. It only works if the warning comes early. And that is exactly why buying those extra days matters so much. A storm you see coming a week out is a storm you can prepare for. A storm that surprises you is the one that hurts people. This matters more than you might think because it buys time. And time is everything. Not long ago, a storm like this might have only been spotted a couple of days before it hit. That is barely enough time to warn people, let alone get ready. But now, thanks to those flights and better tools and faster computers, the warning window has grown. Emergency crews get more days to prepare. Extra days mean extra time to hand out sandbags to clear the drains, to tell people in danger zones to get out early. Extra time saves lives. But knowing the storm is coming is only half the battle. The other half is figuring out what to do with all the water once it falls, and that is where things get surprisingly tricky. California has a huge system of man-made lakes called reservoirs held back by giant dams. These are basically enormous water tanks for the whole state. In a normal year, they collect water in the wet season and hold on to it, then let it out slowly through the dry season when everyone needs it. That is the plan. Save it up, use it later. But when a big storm is coming, the people who run those reservoirs face a hard choice. If a lake is already pretty full and a huge storm is about to dump even more water into it, that lake could overflow, and an overflowing dam is a real emergency. So sometimes, before the storm even arrives, they let some water out on purpose. They lower the lake to make room so there is space to catch the flood that is coming. It is like scooping some water out of a full bathtub before you turn the faucet back on so it does not spill over the edge. Simple, right? Except it is not simple at all, because water in California is precious. Letting it out means it flows away to the sea and is gone. If they let out too much, and then the next few months turn dry, the state could be left thirsty, wishing it had kept that water. But if they let out too little and the storm is huge, the lake could overflow and cause a disaster. It is a nerve-wracking guessing game, and people remember what happens when it goes wrong. At one very large California dam years ago, a giant storm arrived and the lake behind it filled up dangerously fast. The main path built to safely release the extra water got badly damaged. Suddenly, there was a real fear that the whole thing could fail and send a wall of water rushing down into the towns below. The people in charge made the call to evacuate. Nearly 200,000 people had to leave their homes right away, with almost no notice, all because of a storm in a lake that filled too fast. In the end, the dam held. But it was a terrifying reminder of how much is riding on getting these choices right. Now, here is where the better forecasts come back into the story in a really clever way. Because scientists can now see storms coming with more warning, they have helped invent a smarter way to run these reservoirs. Instead of following the same old rigid rules from long ago, the operators can now peek at the forecast and make better choices in real time. If the forecast is clear and no big storm is coming, they can hold on to more water, keeping the lake fuller because they know they will not need the extra space anytime soon. But if a storm is on the way, they can lower the lake ahead of time to make room. It is like a person who checks the weather app before deciding whether to carry an umbrella, instead of just always carrying one or never carrying one. This smarter method started as a test at one lake, worked beautifully, and is now spreading to more places across the state. And the best part is that it lets California store more water using the dams it already has without building anything new. It is a quiet, brilliant win, born straight out of all the pain these storms have caused. So the state is not standing still. It is watching the sky, flying into the storms, and getting smarter about handling the water. But even with all of that, there is a bigger question hanging over everything. Because as amazing as all this is, these storms may be getting stronger. And to understand why, and to see just how bad things could get, we have to go all the way back to one winter, more than 150 years ago, when a storm like this did something almost unimaginable. Part 5, the storm that turned a valley into a sea. To really understand the threat California is facing, you have to know the story of the worst storm it has ever seen. And it happened a long, long time ago, back when there were no satellites, no forecasts, no warning of any kind, just the storms and the people caught underneath them. It was the winter of 1861 into 1862, and that winter the storms did not stop. One atmospheric river after another lined up over California and poured down for weeks, not days, weeks. The rain fell and fell and fell far beyond anything people had ever seen, and then something happened that sounds almost impossible. The giant flat valley in the middle of California filled up with water. Not a puddle, not a flooded street. The whole valley turned into a lake, an inland sea stretching about 300 miles long and many miles wide. Towns vanished under the water. Roads were gone. People traveled by boat over land that had been dry fields just weeks before. Farms, animals, and homes were swept away. It was one of the greatest floods in the history of the state, and it reshaped the land itself. Try to really picture that for a moment. You're standing on your farm, on solid, dry ground where you grow your crops and keep your animals. Then the rain starts, and it does not stop for weeks. The water creeps in. First, it is ankle deep, then knee deep. Then it is over your head, and it just keeps rising. Fences disappear. Barns disappear. Whole towns slip beneath the surface. And when you finally climb to high ground and look back, the land you knew is gone, replaced by a sea so wide you cannot see the far side of it. Boats are sailing over the place your house used to be. That is not a scene from a movie. That really happened right there in California, and there was no warning of any kind. People simply woke up to a rising world of water and had to save themselves however they could. Now, here's the part that should make you sit up. Scientists today study that flood very carefully, not just as history, but as a warning. They use it to imagine what would happen if a storm sequence that huge hit California again. And their answer is sobering. Because California today is not the empty land it was back then. It is now packed with millions and millions of people. Huge cities, highways, farms that feed a big part of the whole country. If a flood that size happened now, the damage would be almost beyond counting. It would be one of the worst disasters the country has ever faced. And that leads to the biggest question of all. Are these storms getting stronger? Could a flood like that one be more likely today than it used to be? Here is where we come back to that sponge idea, because it explains everything. Remember how warm air holds more water than cold air, like a bigger sponge? Well, the whole planet has been slowly warming up. And warmer air, all around the world, means the air can now hold even more water than it used to. A bigger sponge in the sky. So when one of these atmospheric rivers forms and starts scooping up moisture over the warm ocean, it has the chance to grab even more water than a storm would have grabbed in the past. And more water in the storm can mean more rain when it lands. Scientists have looked closely at this, and here's what they have found. The number of these storms might not change all that much. California may not get a lot more of them, but the strong ones, the dangerous ones, are likely to get stronger. In simple terms, the future may hold fewer gentle storms and more of the truly wild ones. Fewer soft rains, more monsters. There's another strange effect too, and it makes life even harder for the people managing water. California is starting to swing wildly between too little water and too much. It will bake in a long, dry stretch, and everyone worries there is not enough water. Then, out of nowhere, the sky rivers show up and dump so much water so fast that the worry flips to flooding. Bone dry one year, drowning the next. It is like a seesaw that keeps slamming from one extreme to the other, with less of the calm, steady, easy weather in the middle that the state was built around. Think about how hard that is to live with. In a dry year, everyone is told to save every drop, take shorter showers, let the lawn turn brown. Farmers are told there may not be enough water for their crops. People start to believe the drought will never end. And then, almost overnight, the sky rivers arrive, and the very same state that was begging for water is suddenly drowning in it, watching the news show flooded streets and rescue boats. Too little, then far too much, with barely any of the calm middle in between. It plays with people's heads, and it makes planning almost impossible because you never know which version of California you will wake up to next. That swinging back and forth is a huge problem. All of California's dams and lakes and canals were designed a long time ago, based on how the weather used to behave. They were built for a steady rhythm, snow piling up nice and slow in winter, melting nice and slow in summer. But the weather is not following that old rhythm anymore. Now storms can arrive as warm rain instead of snow, or the snow can melt too early when a warm sky river washes over it, throwing the whole careful system out of balance. The people who manage the water are working hard to keep up, but the rules of the game are changing under their feet. So, is this next storm the big one? Is it going to be a repeat of that terrible winter long ago? Honestly, probably not. Most storms, even strong ones, are not that catastrophic. But the truth that scientists will tell you plainly is this. They cannot yet say exactly how much stronger these storms will get as the planet keeps warming. They know the trend is pointing toward more intense storms. They just cannot say precisely how far it will go, or when the next truly historic one will arrive. It could be a quiet few years, or the next huge one could already be forming out over the ocean right now as you watch this. And that is the real reason everyone is watching the storm approaching California so closely today. Not because they know it will be a disaster, but because they know what these storms are capable of. They have seen the broken walls, the flooded towns, the mud coming down the burned hills, and the valley that once turned into a sea. They know the land has not changed. They know the rules of water and warmth have not changed. And they know that a warming world may be quietly loading these storms with more power than ever before. The mountains are still there, ready to wring the sky dry. The valleys are still there, full of people. And out over the Pacific, another river in the sky is taking shape and turning toward the coast. What it does when it arrives, no one can say for certain. All anyone can do is watch and prepare and respect the strange and enormous power of a river that flows through the sky. If you made it this far, you now understand something most people walk around never knowing, that there are rivers flowing over our heads, carrying more water than the Amazon, shaping whole states, while most of us never once look up. If this blew your mind even a little, do me a quick favor and hit that like button, subscribe, and turn on notifications so you never miss the next one. We dig into the biggest forces on our planet every single week, and trust me, you have not seen the wildest ones yet. Now I want to hear from you. If a storm like that ever headed for your town, do you think you would be ready? Or would it catch you completely by surprise? Tell me in the comments. And if you want to keep going, check out the video on the screen right now, where we break down another force of nature that is quietly changing the world around you. See you in the next one.